Good afternoon, everyone, or good morning or good evening, depending on where you're joining us from in the world today. Welcome to our first Rockflow Dynamics webinar of the year. Happy Valentine's Day, and thank you very much for signing up for a date with tNavigator today. My name's Joanne Lamb. I'm the Sales and Marketing Coordinator here at RFD in Aberdeen. And today I'm joined by my colleague Mike Smith, who is one of our reservoir engineers and the head of training for the Europe region as well. So Mike's going to be taking you through today's webinar. This is our first webinar for this year. Today we're going to be focusing on simulation. I'd really encourage everyone to give us some feedback after the webinar. Let us know what you think. If there's any topics that you'd like to see in future webinars, please do let us know. We can try and include that. We've got about 60 participants today, so everyone's going to be in listen-only mode for the duration of the webinar, just so we can avoid any distractions from background noise and everything. But please do use the chat box to ask as many questions as you'd like throughout the webinar, and we'll try to answer those as we go along, and then we've got some time set aside for Q&A at the end as well. So that's enough from me. I will hand you all over to Mike now. Thank you very much again, everyone, and I hope you enjoy the next hour.
Cool, thank you very much for the introduction, Joanne. Hello everyone, thanks for logging in, and it's lovely to be here showing off our true dream boat, tNavigator, on Valentine's Day. We'll first start off with a quick presentation about tNavigator and the main scope of the actual webinar itself. We'll then follow this with a live demonstration of the software, and afterwards we'll answer as many of your questions as possible, as Joanne just mentioned there. So what is tNavigator? tNavigator is a single memory-based technology which allows you to build models, simulate and quantify uncertainty in the reservoir and at the surface. The starting point of the ultimate workflow, though, starts with geological models. So what we can do within tNavigator is we can actually go from a blank page, upload some seismic, and then do seismic interpretation, analysis on your seismic as well, building faults. Ultimately building your static model, assigning properties to your model, and then we can do things like well correlation, designing or importing your own faults, facies analysis, petrophysical modeling, and build a schedule section as well. So ultimately your aim is to build a dynamic model ready to be imported into your simulator. Now, simulation is our bread and butter. It's where we started, it's where our RFD started. So we are parallel from the ground up, as we'll see in a couple of slides' time. And we also work with black oil compositional models and also thermal compositional models. Most recently, we've actually gone into the surface modeling area. So we now have a network designer and also a VFP designer where you can actually design, or either upload or design your own lift curves and tables. And we also then have a uncertainty quantifier as well. So through this, we can do history matching or assisted history matching, and then uncertainty quantification, which is then linked into the geological packages and the simulation packages as well, and in the future will be linked with the surface modeling packages. So this webinar is actually mainly focused on the schedule side of things and the simulation as well. So these are the two modules we're going to use, so our simulator and also a model designer. The model designer is mainly to do with the fluid properties side of things and the schedule side of things as well. So the tNavigator simulator is the fastest simulator on the market. It's parallel from the ground up. For maximum calculation speeds, we can work with any kind of computing hardware, so be it a laptop, a workstation, clusters, and we also use the cloud as well. We're also the first simulator to use a hybrid system with CPU and GPU. Now, this is an optional extra, I guess. It's completely free of charge. You can either just use CPU, or a GPU card will cost you, I mean, ultimately a few $100s. It's a very good answer to have, and it's actually something we're going to be using within this webinar. it's a kind of a double-edged sword. So we have obviously the engine behind tNavigator, but we also have a very interactive and intuitive user interface. So not only are you saving time in your simulations with your simulation time, you're also saving time with your workflows as well. We also import industry standard input formats, and we have some unique features, plenty of unique features, some including things like fracture modeling, sector modeling, looking at streamlines and water flood analysis as well. As I said before, after the simulation part, we're going to go into the model designer. This is where you can actually go back and you can edit your static grid, but also make it into a dynamic grid as well, dynamic model. There's a direct link to your PVT designer and your VFP designers. Through this, obviously, you can then assign fluid properties, so roll poems, equilibrium, rock compressibility, PVT, etc. And then the schedule builder at the end, which is a bit we're mainly focused on, where you can put in time steps, history events, and then a very intuitive way to put in different rules and controls. As I said, the main aim of the model designer is to create a dynamic model ready for simulation and analysis, but you can actually also simulate your model within the model designer as well. So the webinar scope, what we're going to look at is loading and interpolating RFD data to see if we get a good match. We also will then look at relative permeability adjustments, Corey, for again the history matching side of things. We'll then look at forecasting and looking at infill well implementation, so a good method to try and put a well in the best area of your model. And we'll use the simulated graphical user interface and an intuitive way to look at multiple forecast generation in the model designer itself. So without further ado, I'll just get on to the live demonstration of tNavigator. So for those who haven't seen tNavigator before, this is our main window. We saw a brief picture of it in the presentation. Going down the left-hand side, we have our designer modules, so our geology designer, which goes from seismic all the way up to building your static grids. We then have a model designer, which we'll also use more down the reservoir engineering side. PVT designer for obviously building the PVT, matching lab results, lumping, blend experiments, things like that. We have the VFP designer where you can build your lift curves, and network designer for your surface modeling as well. The simulator is obviously something we're going to focus on in this particular webinar, and we also have our assisted history matching package with that as well. Now, just a couple more things on the main window of tNavigator. tNavigator automatically realizes the power of your computer and tells you how many cores you can use. It will also assign the maximum to this. Now, we use something called hyperthreading. So for every physical core within the computer, it will make a virtual core on top of that called a thread. So I'm just going to click in the top left here. And you can see the laptop I'm using is a 4-core laptop. However, it has 8 system threads, twice as many cores. It's going to assign the maximum for us, and we'll just leave it at that. So that's what we recommend to anyone. We also have GPU capability, as mentioned before. This particular laptop has a GPU card inside it. Now, I've just clicked on the settings button. This is a GeForce GTX 1070 card with just over 2,000 CUDA cores inside it. So it's a half decent GPU card. I think currently priced around $600 or $700. So for this, we can speed up our simulations for the webinar today. By doing that, all I need to do is click on the top left, use GPU tick box, and I've now enabled my GPU card. Okay, so first of all, we're going to actually use the simulator side of things. So I'm going to go into simulation and I'm just going to go open here. I'm going to find my model, which is going to be this black oil demo of data. I'm just going to double click on that. And first of all, we're going to see a screen which will tell us, it's a log screen. It's going to tell us information about our model. And on the bottom, as you can see, it's going to tell us how many cores our CPU and GPU we're actually going to use. I'm going to minimize this screen for now, just to enlarge the visualization panel within tNavigator. Let's get rid of that. Okay, so this is our 2D window. We can move it using the right mouse button. You can zoom in using the scroller and left and right mouse button together, puts you back to default. And we have a 3D window as well, which are mainly going to stay in throughout this tutorial. And again, you can move the model around and put it back to default using the left and right mouse button. So the first thing we're going to do is we're going to actually upload some RFD data. So just above all the maps we have on the left-hand side, we have a button called Document. So I'm going to click on Document, and about 2/3 of the way down, we have a button called Load Well Data. I click on Load Well Data, and seeing as we just have a text file with some RFD data on it, so I'm going to click on Well Logs at the base. Click here to add file, and I'm just going to find my file, which is RFT_35, and number 35 is the well the RFT links to. So I'm going to double click on that, and then as you can see, it provides a preview of the exact data we're uploading. So we have the date, which is the 15th of the 10th, 2012. Our data, which is in our case is pressure, measured depth, and well. I'm happy with this. You can change the headers if you so wish. I'm happy with this, so I'm going to click OK. And I'm going to click OK again. And we can visualize these RFT points down in graphs on the left-hand side. And click on graphs, and then we're going to go directly into our well section window. A well section window is where you can compare properties on each individual graph in tracks next to each other. So I'm going to click on my well 35. I'm going to scale it and make it into measured depth. And here we have under well logs my imported RFT pressure. So I'm going to click on my imported RFT pressure, zoom out a little bit, and you can now visualize the line of points that we have imported. Now, this is for the 15th of the month, and actually it's between two time steps, both from the 1st of the month. In fact, the time steps are time step 49 and time step 49 between time step 50. So what we're going to do is we're actually going to ask tNavigator to interpolate this data as well. So we're going to right click on RFT 35 and go configure well log. This is where you can configure your data to be either RFT or PLT. So we're going to select RFT. And it seems like nothing's happened. However, when we run the model, it's going to get to that time step and it's going to show us our configured RFT data. So the next part we're going to do is we're just going to run the model. And I'm going to go back into grid properties and just show you a couple of things about tNavigator. As you can see, we have a time slider at the top. This goes through every single time step. As you can see next to it are the dates and the actual time steps as well. And we save a map for every time step we have. So it's almost, in inverted commas, a live feed to how your model is doing. We also have something called streamlines. So just click on the streamlines here. And if you move maps on the left-hand side, it will populate the correct colors for them. Alternatively, there's a settings button next to streamlines where we can actually select individual colors for each type of well. So for example, here I've selected injectors to have an individual color each, and you can see exactly where those streamlines are going within your model. Okay. So I'm just going to get my grid back. We also have three FitNum regions in this. Going down the maps on the left-hand side, we have things like fluid in place, and we'll actually use mobile in place later on in the webinar. If I expand regions here, we have FitNum, and this particular model has 3 FitNum regions. So what we can do is we can actually specify how to filter to these and actually separate them out into 3 individual layers. So we can use the cut just in the middle panel, and under cut it has all your regions automatically within this. So when you go into FitNum, equals to 1. It's our first FIPNUM region, it's our second FIPNUM region, and our third FIPNUM region. Now this is great. Each region has a value of, let's say, 1, 2, or 3. What we can do is we can actually overlay different properties onto this as well. So I have on the right hand side a statistics button to show you the difference. Has all the entries, the sum of the cells, and then the value at which the layer or the map, whichever you're using, is applied to. So I'm going to click on second region, third region. You can see 3, 2, 1. What we can also do is we can put in something like mobile all in place on top of this. And now it gives us the statistics for our FIPNUM region 1 with the mobile all in place. And again, we can do the same for our middle FIPNUM region and our third FIPNUM region as well. And you can see statistics also changing. So I'm going to get my my model back just now, like so. And we'll go on to look at the way our history match has gone. So to do this, I'm going to go down to graphs, into rates here, and take a couple of these parameters. And as you can see, we have an oil, which is in red, mismatch, and we have a water in blue mismatch as well. So these are our rates. If I expand wells, you can also see this well by well, or at field level, which we just decided to use. On the left-hand side, we can look at the totals as well. So we have our calculator, which is the bold line, and we have the history, which is the dotted line next to it as well. This is also the case for gas, the gas history and gas total. However, we'll probably, for most of our diagrams, we'll probably stick with the oil, and we'll look at the gas as well, but there you go, just for ease and better visual. Okay, so what we can do now, so we've looked at our rates and totals. We're now going to look to see how our RFT match has gone. So I'm going to go into well section. Here I have now my calculated and interpolated RFT data because we assigned it as RFT and we've run the model. So I'm going to click that on. And I'm just going to change the scale of my well section windows. To do that, I'm just going to go into settings, common bounds, fixed bounds. I'm just going to type in the boundaries I'd like to have so we can both see them both on the same scale here. I'm also going to look at my calculated pressure. So it comes in as one of these. There's just a bar chart at the moment. I can right click on pressure, go into settings, and assign this as points as well. So at the top, you can click on point number 49, the time set number 49, which is where we imported the data. And as you can see, between the dotted line and the normal RFT data, there is a discrepancy. And you can see the same. So if you go up in time step, also you can see a discrepancy as well. So we're going to try and match our RFT to our calculated as well. Now, just below this, we have a graph that shows how our historical, how history match has gone into well by well. So if I move the time slider along, you can actually see which wells are out of the tolerance we set for our history match, and also gives you the data on the right hand side. And just underneath that on the left, you have unified history matching results, and you just get the table form of this as well. So you can see relative mismatches, one of them here being 18, for example, for oil total, and absolute mismatches here as well. So you can actually specify which tables you'd like to see. We're just going to leave this for now. And lastly, we have our well RFT mismatches table as well. So we can actually see the mismatch between our RFT data and our calculated data as well. Okay, so what we're going to do next is we're actually going to try and history match our model by changing the relative permeabilities of the model. And there's two ways to do it. The first way I'm going to show is just a bit of a demonstration, but we won't actually use this method for the webinar, but it's just a demonstration side of it. So let's go into fluid properties at the bottom. And here we have our roll perms. This is our water oil roll perm here. I've actually have a backup model just behind my screen here. I'm just going to open the manual RFD data. Just to show you on another model, it's an identical model. And here we go. So if I now hold the shift button, I can actually physically move my relative permeabilities or PBT data. And you can see on the right-hand side, the table, the actual numbers are also moving with this. This is a very intuitive way of doing it. Saves you a lot of time, even if it's just for a simple way of managing the data. Now, this is just a quick way to show you. We're actually going to go back into our other model again. And we're going to convert our relative permeabilities into Cori instead of manipulating our rel perms physically. So to do this, firstly, because we've already calculated our model, I'm just actually going to reload the model so it resets. And then we'll go into document at the top, and it's just an approximation of our rel perms. So document on the top left, and then approximate RP. Convert to Cori correlations. You can also convert to LET correlations as well. I'm just going to convert to Cori here. And it shows you where the dotted line is where our current relative permeability lines are. And then with these numbers on the right-hand side, it shows you with the bold line here what they would look like. We're actually going to change a couple of these numbers just to try and match our history slightly better. So bear with me just a second. 0.4, 0.2, 5, and 5. And as you can see, while I'm doing it, it uploads straight away, or updates straight away on the graphs on the left-hand side. And lastly, I'm going to change this to 0.5. Perfect. There we go. So you can see our curves are much smoother. They've also changed a little bit. So we'll see some different results. I'm now going to select create Cori keywords at the bottom, continue and reload. And it's now going to just implement these changes for us. Okay. So just a quick heads up to what we've done. You can actually see our curves now in our fluid properties. There's our gas, there's our water. We can also see what we've done in table form. Now, we have some things called user files, so you're never actually overwriting your base case. What you're doing is adding, if you change your model in any way in the simulator, you're just adding to your case. And it creates an additional text file. In a way, almost the same as an include file, but it's almost a silent include file. So I can go see all my include files and results files and user files up in the files button at the top. And we have includes their results, and we also have some user files. So it's obviously looked at our RFD and added it to the schedule, and we now have _rp.inc. So just click on that, and you can see the differences and what it's actually now taking for our relative permeabilities, including the keywords above. So Cori Woe and Cori Go as well. So what we can do at this point is we can run the model and see how it affects our history match. So again, just going to go into the top big red button at the top and click run. And meanwhile, I'm actually going to make some graph templates just so we can have a good little view on how we are, good view to visualize our data. So just going into graph templates at field level, adding my templating on template options. I'm going to go for a grid of 6. So, and I'm now going to have my rates on the left and my totals on the right. So, along with the history. So, we're going to go gas rates versus history on the top, oil rates versus history in the middle, and below that, water rate and its history there. And just on the right hand side, do exactly the same for the totals. Thanks. So now, as you can see, there is a vertical line hovering across our graphs. The match was actually quite good at the start of the model, and then it got more deviated after it. But as you can see live, we are now seeing our history matching, sorry, our calculator much matching our history much better as a live feed. So you can always see your previous results and see how they're live updating as well. Excellent. So we've now finished our simulation, thanks to the GPU card we're using. I've saved the templates, I've gone back, and what you can do is, here's our template one, I can right click, I can actually export this template from this model. If a reservoir engineer has a particular view that they like, they can export the template and import it again back into their model. So once you've done this, we can actually see how this has affected the other graphs we have. So I'm going to go back into graphs. We can now go down into our historical versus calculated. And where we had some wells outside of our tolerance, we now don't have any outside the tolerance. They're all inside and all marked green, including with the data on the right-hand side. This can also be seen in the history matching results, where we have much smaller relative mismatches than before. And also this goes for the RFT mismatch. So where the RFT before was around about, had a mismatch around about 30, we're now down at about 5. So let's actually see our RFT data. We'll go back into the well section, and we have our data here. So I'm going to go tap in back into time step 49, and you can now see that we have a perfect match, or almost perfect match, in between our calculated and our RFT data. More to the point, this is obviously for a time step from the 1st of the month. It's the 1st of October here. Our next time step is on the 1st of November. However, this green line is our calculated RFT from the 15th of the month, which should be directly in the middle. So if I go on to the next time step, you can now see our calculated pressure the other side, and the interpolated RFT data will now sit in the middle. Okay, so we're now happy with the history match. We're going to show a couple of ways to look at creating a forecast. So one of these methods will be within the simulator, and one of these methods will be in the model designer as well. So firstly, with the simulator, top left, we're going to go into documents, and just below where we had approximate RP, we have create forecast. So this is now going to create a forecast for you. You can either select it with the time slider at the top, or you can manually select the date at which you would like your forecast to start. Now we're just going to use it on the final time step. We would like monthly time steps for this as well. And we're just going to run a forecast for about 3 years. So it's going to take us up to 1st of Feb 2018, so only half a month out. You can then select any kind of options you'd like within your producers and your injectors. So I'll just untick gas injectors because you want to keep these as water injectors. And what we're going to do is we're just going to keep controls the same as they were at the end of on the final time step. So we're now happy with these controls here. You can actually put any kind of controls you like into this. We have open forecast model ticked on the bottom. I'm now going to click OK. And we now have a forecast model. Like so, which, as you can see, has a yellow bar at the top. Now the yellow bar is obviously the time steps on the previous case, and the clear bar is the area where we are going to run our results. So this is 3 years from the time slider to the end. So what we're going to do actually is we're now going to have a look at a couple of methods as to how we can select the correct, a good area to create an infill well using the grid properties, and then we'll run it and see how this affects our data as well. So going back to the 3D window, we have mobile oil in place. Now, for the mobile oil in place, this is probably one of the better maps, I think, along with oil saturation, etc., to look at an area where you can put an infill well in. It is, however, fairly difficult to look at the exact good places. I mean, we have high points potentially at the bottom here, However, to delve into the model, it's fairly difficult. So what we're going to do is we're actually going to apply a filter. So we're going to go on the left-hand side again and expand user cuts and click on cuts. Now, at the bottom of this, you get an arithmetic command line where you can put any formula you like, if functions, else functions, etc. To the left of that, we also have a calculator. So I'm going to click on the calculator, and we have a list of all the maps, as you can see, in the calculator as you do on the left-hand side. So firstly, I'm going to expand fluid in place, and I'm going to select mobile in place, followed by enter. This is now identical to the map we just saw from the left-hand side. However, it is a static map for the time step that you selected the map to be on. This has its own benefits. If I move the time slider, it's a snapshot in time. I move the time slider back. However, if you'd like this to be a dynamic map, I can go onto the left-hand side, right-click on cut, and select auto update, and you can now see cuts gone green. And if I move this along, you can see through time how a map has become dynamic. But again, we need to look through the model to actually see where the high points of oil in place are. So going back to the formula bar at the bottom, we have our mobile oil in place is greater than 200 SM standards cubic meter. So I'm just going to click OK, and we now have a model which has 0 points as blue, and we then have 1 as the red points. Now these points are only satisfying the function we have below, so it's a kind of binary exercise, I guess, in this part. And again, what we can do, like we did before with use cuts, is we can now use our cuts and actually see these individual cells being mapped. We can now actually overlay this cut with our mobile oil in place map. So we go onto the left-hand side and click mobile oil in place, and now we can actually have a much better view on a decent place to actually put an infill well. Now, from my knowledge of this model, actually we have a sealing fault going down this southern or south eastern front. So I might refrain from putting a well in there. However, I can see a couple of nice areas just in the northern area of the base here. Excuse me. So what we can do is we can put in a cross section, and we're just going to put a vertical cross section in and visualize this in the 2D window. I'm going to go to the top right hand side, and it's the third from the top. We have create a cross section. Click on that, and it's going to give us a number of options as to how we should create a cross section. We're just going to use a vertical cross section. I'm going to pick a couple of points, just 2 points, like so, and you can see where our cross section is going through the model. Now I can either rotate the model using the cubes on either side of it, or I can change or completely move the model using the yellow sphere or circle as well. Now, once you're happy with the cross section, you just press close. tNavigator automatically saves anyway, so the cross section has been saved. We can now visualize this cross section in the 2D window, where we have a drop-down box that currently says roof, defaulted to roof. If I click on that and go cross section at the bottom, we can now see our cross section. Now, I'm going to have some grid lines to this. You can see the high points of mobile oil in place, but you can also see some areas that don't have active grid cells. This is actually, and you can see them at different angles. This is actually because we put in a vertical cross section which will cross certain cells at various angles. So it might not actually be, in this case, the best cross section to use. Another option we can use, and we will use now, is we can actually create an option using the sum part of the 2D window. So instead of going into cross section, I'm actually going to go from cross section up to sum. Now this gives us a summation of all the K values as a 2D map. This actually now gives us a bit of a better view, certainly a different view of our high points of oil. So just in this area to the right hand side, you can see almost a nice L shape. And this is somewhere where we can try and populate. I'm now going to create a second cross section. So back onto the right hand side, towards the top, create a cross section. But this time, as you can see, our vertical cross section crosses through there. I'm going to create a second cross section using the add new cross section box. And I'm actually this time going to use point selection. So point selection allows me to click on any of the grid cells to create a cross section. So I'm going to create one like so. Just going to go in individual cells, and this should try and mitigate the way that the cross section actually crosses its cells, or the poor visualization of it, let's say. Okay, so I'm happy with my cross section. I'm going to click close and go back down to cross section again, and suddenly we have a cross section without the issues we had before. Now, looking at this cross section, I have a nice little area to add in a new well. And this is what we're going to do now. So I think the driller would be pretty happy if I went down dip a little bit. So let's start from the left-hand side. And we're just going to populate this in the second full cell. I have two options. I can either right-click on Add Well on the cell I'd like to put it in and go Add Well, or I can hold the Alt button and just left-click, and it will automatically put in a vertical well for us. So I'm just going to pick this second cell down, Add Well, and as you can see, we have a well dialog box that's appeared, and we also have a vertical well. Now you can change the name of the well, you can change its controls, economic limits, etc. And as we said before, it was a vertical one. However, this would not get the best benefit out of the area we'd like to add the well. So we're going to make it deviated. So it's the vertical, in the center of the box we have deviated, and now vertical well disappears. I'm now going to hold the Alt button, the ALT button, and just left click where I'd like my well to cross, like so. And as you can see, we're going down dip, and each one of these connections will put in a perforation for us as well. So it's currently IJK, and let's finish the well just here. So you can zoom out, have a look to see what your well looks like. I'm happy with that well. And again, we can put in different controls. I'm actually happy with the controls we have here at the moment, just to keep it simple. And we're now going to click Add Well. Now the well disappears because we're currently at the end of the 77th time step. Therefore, it will be at the start of the 78th time step. So let's now run our model. And click on the red Run button. And we can now see our well that has been populated and is now actually changing. And our oil is actually, oil saturation is now changing throughout time as well. We can also put a bubble map on this. So you can see, I'll move the time slider back again in a second so you can see a better version of it. Yeah, so if I now move my time slider back, you can now see the bubble map and how the water cut increases, or water production increases throughout time. Okay, so we've now shown a way to use the forecast functionality within the simulator. We're now going to try and look at it in the model designer as well. So I'm just going to come out of this and go back into our main window. So in this point, we're now going to use the model designer, so I'm going to go to new. I'm just going to make sure it's in the right folder, call it forecast. Click save. Just thinking. There we go. It's now going to ask us which modules we'd like to use. We just need a model designer for this one, but if you also want to use the geology designer, then you're free to use that as well. I'm happy with that. I'm just going to click OK. Excellent. And we're now just given a blank screen. So again, I'm just going to minimize the log bar at the bottom for better visualization. Firstly, I'm going to import my model, and we have two ways to do this. We can either import data from rescue files that come from other model builders, or we can just import data from existing models. I have an existing model, which is my data model here, and just here is my model with the acronym. So I'm now going to actually take the acronym out of it by going into grid settings, filters, and then by going use cut, again, just the filtering section, I can click on acronym, and hey presto, we have the same model as we've just been looking at. This is just with the porosity map on top of it as well. Okay, so we're going to create 3 forecasts. One of them just using the original controls. The second one, we're going to shut off the injectors, and the third one, we're actually going to put in a water cut limit to change some of the perforations. So first thing we're going to do is we're going to increase the time steps again to a 3-year forecast. To do this, just where the time slider is, there is a pencil with a clock next to it. So I'm going to click on that. It's our time steps editor. These are our current time steps. I'm going to click on our bottom time step again, and underneath there we have add steps. So I'm going to click on add steps, and I can either add in a single step, or we can do it in intervals of the ones you see here. So I'm now going to click on monthly time steps, so 1 month, up to the 1st of Feb 2018. Click OK, and we can now see our new time steps in our time steps editor. So click close. If I go into Wells data at the bottom and into rules, we also have a visualization of where our time steps are. There we go. So we now have 15th to the 17th and 18th years. You can also see the rules that have been applied to our previous time steps. So if I expand a couple of these, we have the user keywords from the import, and I can click on them, and we now have a visualization of the kind of schedule in table format. So I can click on these and see how they change. Okay. Now we're at the moment playing with a single model, and so what we'd like to do is create a couple of realizations of this model to play with. So at the moment we have our single model at the top, which is called model. If I right click on this model, I can click duplicate and select a new name for it, forecasts 1. Click OK, and we now have forecast 1, which will have our new time steps in there as well. And again, I'm going to click duplicate, forecast 2, click OK, and we have our second duplication. So what we're going to do is we're going to run our model just so we have some base results, and then do some comparisons afterwards. So the big green button I just clicked was the initialization part. The model is now initialized, and again we're going to go into the big red button at the top and look and make a graph template with this as well. So I'm going to make a very quick graph template, just down in graphs at the bottom for visualization. Click the plus button at the bottom. Make sure it's a model on there. And again, go into the settings button for this, and we're just going to click on 4 different selections here. So we're going to say have say rates and totals. That's it. So we're going to have oil rates versus water rates on this top one here. We're going to have the totals for these on the next graph. Let's put some water cuts on the third one, and finally we can put in, let's say, water injection rates on the final graph. Perfect. You can now see how these are being populated as well. If you wanted to look at the results on the right hand side, you can also see how these are being populated. And very soon we will have our run all finished. Perfect. So we now hit the point where we're in our forecast. We'll see around 2015 was where we previously had it. I mean, you can now see with our base changes, we have fairly consistent results. Excellent. So the next part is we want to try and change something, and we'd like to go back into definitions at the top, where we have our 2 extra forecasts. And I'm just going to right click on the forecast we'd like to select and go set current. Okay, so it's now selected it in bold. We can now go back down into Wells data and into the rules. Now we can see where our forecast started because these arrows have changed. So I can right click on the time step and select add new rule. And this gives us a large box of different options for us to add different rules into our wells here as well. So you can either put them in as keywords, make groups, do flooding, or you can just do simple well controls. This particular one, we're actually just going to use well injection limits in order to shut the 6 injectors off and see what happens. So I'm going to select well injection limits, click OK, and I want to, instead of selecting individual wells and it being a bit lethargic, or selecting all the wells, which would kill the producers as well, we are going to create 2 filters, one of production wells and one of injection wells. And to do that, on the right-hand side, we have use well filter. So I'm going to select a well filter just for all my wells, create a second well filter for producers, and which are the following wells. Excellent, and we're going to create a third well filter for the inverse of what we just made. So 24, 26, 34, 36. And I'm happy with those. And put all wells back on. Perfect. So we have our well injection limit. So I can now go on wells from filter or wells and select my injector well filter here. Well status, we can check to shut, which will then shut in all these wells. Once you're happy with your rules, we can go back up into definitions again, and we can, first of all, save the project, good practice, and then initialize our model. You can see all the log screen at the bottom, it's telling us our fluid in place, things like that. We can now run our model, go down into graphs, and see how our model is being calculated. Not only that, but we can also compare it by holding the Shift Control button to our previous model we have just run. So we just had a couple of questions as whilst this is simulating here. So one of the questions we've had is, can we use tNavigator for enhanced oil recovery modeling? The answer is yes, as we just saw under well data here. If I can make another rule, a different time step, we can see the different types of flooding we can do. We also have various keywords within the user manual. We can do things like polymer flooding, surfactants, and even bright water technology as well. Go back and see how our wells are doing here. So we're now just about to get to the time where our injectors are going to shut off. And it will just populate in a second. Excellent. So now we can see on the bottom right graph, we can see this is our water injection rate. It has dropped to 0. And you can see how our water cuts and water rate and water totals are also dropping. However, it does also see, and I mean, we can see that the oil rate is slightly dropping and the oil total is slightly dropped. However, in the grand scheme of things, I don't think this is such a bad result. This is the comparison. This is how it looks like without the comparison, and then this is with the comparison as well. Excellent. So this is our first forecast. So we can now play with our second forecast and go into definitions at the top. So again, I can just right click on forecast 2, set current. It goes bold, and we'll say model and initialize our new model. Okay. In fact, before we should have initialized the model, we should have actually gone and changed one of these controls. So I'm just going to close the dynamic model, go into Wells data, and actually on the, let's pick a time step. Let's pick this time step here. Let's go add new rule. And we will put an economical limit in. So we're going to put an economical limit for production well. Click OK. And we're actually going to say maximum water cut of around 80%. And we're going to say to the well, actually shut the worst offending perforations off. Okay, so we can upload these in. Say wells from filter, we want this to happen to our producers at the top. And now above we can go into initializing our model. Once we've done this, we can now run the model, and again, on the graphs, you can see how our forecast 2 data is also coming on. Now, just a couple more questions come in whilst we're looking. We have a question from, we have a question that's basically along the lines of, is it possible to average the loaded production date into different time intervals for export purpose? For example, monthly, bi-monthly, yearly. The answer to that is yes, you can. We can load this, we can actually look at this in the graph section in the simulator as well. And I'll just check to see if we can do it here. Yes, this is it. So here we can also look at all dates, monthly dates, and we can look at average as well. So thank you for your questions, keep them coming. And we're now just coming towards the end of our final forecast. Where it's now across the 2015 point, and we'll now see where the water cut starts to hit the wells with 80% water cut. You can now see how their perforations are being shut off and extrapolated from here. And this is what the graphs look like without comparison. We can now compare these with our initial forecast. So our model number 1, you can see big drop off in water rates. However, we can also see a slight jump and then drop off in oil rate as well. This can also be seen now with the totals in the top right, and also the water cut here and the injection rate. Ultimately, we can actually, if we really wanted to, compare all 3 of the models on the left-hand side and see the different results we have. Now, obviously, these results will be different for different circumstances. I like the look of forecast 1, in my personal opinion, because there is a drastic difference in water rates than oil rates. However, these can then be looked at for analysis and even more realizations made of these. Whilst you're on the topic of realizations, we're just coming to the end of the webinar now, but we can actually show how we would create external geological realizations as well. So I can go into document at the top, set onto workflows, which is towards the bottom, and then top right we have import workflows. This is a Python script. We can also create these ourselves, but I have one already set up. So I'm going to go import workflow, and we have my webinar Python script here. Now here we just have a workflow where I've added in certain variables to certain parts of my model. So for example, I have a variogram looking at my porosity, and you can see I've added in some variables in these areas here. We also use, you can also use variables for your interpolation method as well. So for random number, I've now put in a certain variable as well, and also for Permex, you can use different variables. As said before, these are the variables we've used, and all we'd have to do then is click the run workflow, and then we can do some uncertainty analysis on our geological realizations as well as our forecast realizations as well. However, we'll save that for another day. Thank you very much for listening. Let me just share the screen back. Okay.
Thank you very much, Mike, for the demonstration. I'm sure everyone enjoyed that. We'll just go on to some questions now. While we're just gathering up the questions, I'll just let you know about some of the events we've got coming up in Europe over the next few weeks. So we're doing a free simulation course we'll be in London on the 28th of February and Aberdeen on the 1st of March. And then we've got our annual user group events coming up in Norway next month as well. So on Tuesday 13th of March, we're going to be in Stavanger, and Thursday 15th of March in Oslo. So if you've got any questions, or if you want any more information on the events, please just drop me an email and I can let you know. What questions have we got coming in? What is the added value of having the model designer compared to just the simulator? Nice question.
So the simulator, obviously we started with the simulator. It's actually quite funny because most people start with the geological side and then go into simulation. So we've had to almost backtrack a little bit. What's the advantage? Mainly the advantage is the fact you can make your dynamic model in the model designer, whereas you can't really do that in the simulator. The simulator is literally just there to have a fully working dynamic model and run it through and do analysis on from that. Whereas the model designer, we can get a static model. We can even do a few changes to the static model, like add in aquifers or local grid refinement, and to then add in things like your PVT properties or RelPerm properties, any kind of fluid properties. And then, as we just did with the schedule side of things, you can build the schedule. You can do that. You can do bits of those in the simulator as well, like create a forecast, which we just showed you. However, for that side of things, you would rather go. I think the workflows are easier in the model designer, as the same as the analysis is better in the simulator as well. However, they do both use the tNavigator engine behind them as well.
Okay, we've got another question here. How do you upscale in tNavigator?
Upscaling, so we can upscale properties. So when you use logs, for example, you can upscale the log to fit the actual grid itself. However, in principle, we are against the concept of upscaling. So for reasons that we have such a strong engine that we actually believe that the bigger the model, almost better. So we'd actually encourage people, rather than upscaling, to keep your fine grids and then just add hardware, which will cost you, which won't cost you anything any more than using it on a laptop, for example. So that's the main kind of vision that we have, I guess.
Okay, I think we've got time for one more question. Is the way of calculating VFP different than the other simulator?
So the other simulator, I assume you mean competitive softwares. As far as we're aware, not particularly. Actually, the VFP designer only came out. We have 4 releases a year, so 4 new versions a year, which means we can actually get a lot of development into tNavigator very, very quickly. So actually, the VFP designer only came out in December 2017. So currently, it's no, sorry, I lied. No, it was December. Sorry, it was December 2017. So it's currently in a fairly kind of primitive form. However, give it 1 or 2 more version releases. Our next actual version release is going to be early April. Give it 1 or 2 version releases, and you'll have much more functionality within that.
Okay, we'll do one more question. Can tNav read from Petrel Other question, can Petrel use tNav as simulation engine?
tNavigator can read from Petrel if you export it in either E100 or E300 formats, or you have things like eGrid, GridECL. Well, they can be loaded into the designer part, but mainly E100, E300s. We also use rescue formats as well. So if you have a model that's kind of half built, you can export that in rescue formats and populate it in there. The second part of your question, can Petrel use tNav as a simulation engine? Yes, it can. We have a tNavigator plug-in into Petrel, so we can use the engine behind tNavigator within Petrel. So yeah.
Okay.
Thanks for your questions.
What we'll do is we've had quite a lot of questions in, so if your question wasn't answered, we'll compile them all together, get all the answers and email that out to everyone. And we'll also send out a recording of the webinar as well, should you wish to share that with any of your colleagues. So thank you very much everyone for joining us today. Thank you, Mike, as well, for the great presentation. And hopefully you'll be able to join us for our next webinar in May. Thank you very much, everyone.